Welcome to The Explainer. Today, we are diving into something pretty wild. It's a paper that doesn't just question a few equations. It claims that the very foundations of modern mathematics are not just wrong, but a deliberate, centuries-long fraud. Right out of the gate, the author Miles Mathis makes this huge claim. He's not here to make small corrections. He's basically saying he's going to burn the whole house down, starting with everything we've learned since the time of Euler. Okay, so where do you even start with a claim that big? Well, funny enough, the critique doesn't begin with math at all. It starts with a person, the legendary 18th century mathematician himself, Leonhard Euler. So the author starts digging into Euler's personal life, looking for what he calls red flags. He points out that Euler came from a privileged background, had powerful connections, and, get this, that famous figures like Frederick the Great and Voltaire supposedly thought he was a fool. He even dismisses famous problems Euler solved, like the Seven Bridges of Königsberg, as basically being child's play. And here's where he makes his first big leap. The whole point of this biographical stuff isn't just historical gossip. The author's thesis is that if you see these patterns in the man's life, you should be deeply skeptical of the math he created. It's a foundation for the whole argument. All right, so with that set up, let's get into the real meat of the argument. The paper launches its most direct assault on something you probably remember from school, the foundations of calculus. Remember this beast? This is the formal epsilon delta definition of a limit. Yeah, I know. If you've ever taken a calculus class, this is the kind of thing that probably gave you a headache. But for centuries, this has been the rock-solid foundation of mathematical analysis. Well, here's the author's reaction to that definition. He calls it criminally squishy. The whole idea of numbers tending to or approaching something, he says that isn't rigorous at all. He thinks it's just vague language that opens the door for all sorts of mathematical tricks and manipulations. So you've really got two completely different worlds here. On one side, you have mainstream calculus, built on these slippery ideas of limits and getting infinitely close to something. On the other side, you have the author's proposed alternative, a system built on concrete things like finite differences and definite lengths. In his world, a number is a number, period. No approaching allowed. And you might think he'd stop with Euler, but no, the critique keeps going. The next giant of math to come under scrutiny is Bernard Bolzano, a guy who's usually praised for making math more rigorous. Now, this is what the history books usually say. Bolzano was a hero because he wanted to purify math by taking out messy, real-world ideas like time and motion. The thought was this would make it more logically sound, more rigorous. But the author argues that this move was the exact opposite of rigor. In his view, this is where everything went off the rails. By separating math from physical reality, you take away any chance to actually test it against the real world. He says it's not rigor, it's just building a fantasy land where you can make up the rules. And this whole idea of tying math to reality isn't just a philosophical debate. It leads directly to what is, without a doubt, the most radical and explosive claim in the entire paper. And believe it or not, it all starts with a very simple question. Seriously, think about it. How do you measure the length of a curve, like the circumference of a circle? We all think we know the answer, right? It involves pi. Well, the author argues that the standard way we do it is completely, fundamentally wrong. Okay, so he breaks it down like this. There are two ways to measure a circle. First, there's the static geometric way. You know, you wrap a tape measure around a wheel that's just sitting there. That tape touches all the points at the same time. But then there's the kinematic or physics way. This is when an object is actually moving along that curve. Now you've got motion, you've got time. He calls the first a three-vector problem, just space. But the second, because it has to include time, is a four-vector problem, a totally different animal. And here it is, the bombshell. The author claims that for centuries, physicists have been making a massive mistake. They get the number pi by using the static geometric measurement. Then, he says, they illegally plug that number into physics equations that are all about real-world motion and time. So, what happens when you do the math his way, when you actually account for motion and time in your measurement? Well, according to this paper, that famous number, 3.14159, is wrong. The real value of pi for anything that's actually moving along a curve is 4. Just the number 4, a clean, simple integer. Just let that sink in for a minute. Okay, so if pi equals 4, what does that do to physics? Well, According to the author, the consequences are absolutely catastrophic. It basically means that modern physics is built on a broken foundation. And he claims this isn't just some abstract theory. He points to things like the early space missions in the 1950s, arguing they missed the moon by huge margins, as much as 20%, because, he says, they were using the wrong value of pi in their orbital calculations. He goes on to argue that this bad math has allowed generations of famous physicists to just fudge their numbers to make the theories work. He lists specific examples, from Einstein's special relativity all the way to how Newton's successors handled gravity. And this quote right here really sums up his final verdict. He's not just criticizing a few equations. He's concluding that the entire academic field of mathematics has become a useless game of self-promotion that has nothing to do with describing reality. And that brings us to the final, unsettling question this paper leaves us with. It forces you to wonder, what if the language we use to describe the universe has been fundamentally wrong for hundreds of years? What does that mean for everything we think we know?